Determine V at when R1 is 180 and XL is 90. A 135.63.4 V. B 13.563.4 V. C 12.20 V. D 122.0 V. The correct answer is 13.563.4 V. For the given circuit, find V at for the circuit external to RL. A 4.6951.3 V. B 4.6938.7 V. C 46938.7 MV. D 60 V. The correct answer is 4.6938.7 V. Referring to the given circuit, find Z at if R is 15K and RL is 38K. A 89.8251.3 K. B 19.238.3 K. C 9.3851.3 K. D 180.38.3 K. The correct answer is 9.3851.3 K. For the circuit shown, determine Z at for the portion of the circuit external to RL. A 66.733.7 K. B 6.67333.7 K. C 14.456.3 K. D 1.4433.7 K. The correct answer is 6.67333.7 K. Referring to the given circuit, what is Z at if R1 is changed to 220? A 225 12.1. B 225 77.9. C 46 77.9. D 46 12.1. The correct answer is 46 77.9. Determine V at for the circuit external to RL in the given figure. A 135.63.4 V. B 13.563.4 V. C 13.50 V. D 135.0 V. The correct answer is 13.563.4 V. Referring to the given figure, determine Z at as seen by RL if R1 is changed to 3.3 K. A 1488.70.7. B 3859.31.2. C 5180.50.5. D 1828.50.2. The correct answer is 1828.50.2. The two basic components of a Thevenin equivalent AC circuit are the equivalent voltage source and the equivalent series impedance. B the equivalent voltage source and the equivalent series resistance. C the equivalent voltage source and the equivalent parallel impedance. D the equivalent voltage source and the equivalent parallel resistance. The correct answer is the equivalent voltage source and the equivalent series impedance. Referring to the given circuit, find Z at if Vs is 18.0 V. A 9.8251.3 K. B 9.3851.3 K. C 180.38.3 K. D 19.238.3 K. The correct answer is 9.3851.3 K. In applying the superposition theorem, other sources are considered one at a time with all others replaced by their internal impedance. B all sources are considered independently. C all sources are considered simultaneously. D the sources are considered one at a time with all others replaced by their internal resistance. The correct answer is the sources are considered one at a time with all others replaced by their internal impedance. If two currents are in the same direction at any instant of time in a given branch of a circuit, the net current at that instant A is 0. B is the sum of the two currents. C is the difference between the two currents. D cannot be determined. The correct answer is the sum of the two currents. The Thevenin equivalent voltage is A equal to the source voltage, B the same as the load voltage, C the open circuit voltage, D none of the above. The correct answer is the open circuit voltage. Referring to the given circuit L, A must be in parallel with RL, B must be placed in parallel with Vs, C must have a reactance equal to Xc. D has no effect on the result. The correct answer is has no effect on the result. Referring to the given circuit, find Zth for the part of the circuit that is external to RL. A 129.21.4, B 43.768.6, C 43.721.4, D 12.968.6. The correct answer is 43.768.6. In order to get maximum power transfer from a capacitive source, the load must A have a capacitive reactance equal to circuit resistance, B have an impedance that is the complex conjugate of the source impedance, C be as capacitive as it is inductive, D none of the above. The correct answer is have an impedance that is the complex conjugate of the source impedance. Referring to the given circuit, determine Zth as seen by RL. A 1444.48.5, B 4176.73.3, C 956.48.5, D 1444.73.3. The correct answer is 1444.48.5. Referring to the given circuit, how much power in watts is delivered to the speaker at the determined frequency if Vs 4.5 V RMS, A 226 MW, B 2.26 MW, C 4.24 MW, D 424 MW. The correct answer is 424 MW. The Norton equivalent current is A the current through the load, B the open current from the source, C the short circuit current, D none of the above. The correct answer is the short circuit current. Determine Vth if R1 is changed to 3.3 K. A 0.574 V, B 4.63 V, C 4.63 V, D 0.463 V. The correct answer is 4.63 V. Referring to the given circuit, what is Vth if Vs 12 V? A 4.69 V, B 9.38 V, C 12 V, D 60 V. The correct answer is 9.38 V. For the circuit given, determine the Thevenin voltage as seen by RL. A 0.574 V, B 5.74 V, C 0.574 V, D 5.74 V. The correct answer is 5.74 V. Determine the frequency at which the maximum power is transferred from the amplifier to the speaker in the given figure. A 1027 Hz, B 10270 Hz, C 6330 Hz, D 63,330 Hz. The correct answer is 1027 Hz. Norton's theorem gives A. An equivalent current source in parallel with an equivalent impedance. B. An equivalent current source in series with an equivalent impedance. C. An equivalent voltage source in parallel with an equivalent impedance. D. An equivalent voltage source in series with an equivalent impedance. The correct answer is an equivalent current source in parallel with an equivalent impedance.